Hey there, and welcome to the second devlog for Hypercastle Explorers. I'm Matto, and in this video I'm going to give you an update on our progress so far building a Unity game engine SDK for the Terraforms by Mathcastles NFT project. Let's get started. Welcome back to our second devlog. Check out the first one if you haven't seen it already, where I'll kind of lay out the basic context of the project. But where we're at now is that we have been working on pulling in the data from the Solidity contract into Unity and figuring out how to interpret and redisplay that in the game engine, right? So reading from Solidity, we're using the Ethereum SDK, right, which is a kind of .NET Ethereum interpreter package that allows us to easily interact between C# land and Solidity. That's open source, and you can get it from their GitHub page. We've incorporated that into our project because it makes it much easier to go from C#, which is the scripting language of Unity, to talk to the Solidity-based Terraforms contract on the blockchain. And so what we started out by doing was saying, okay, we want to interpret the SVG data, which is the kind of current final output that gets displayed on websites like OpenSea, right? If you open one of the Terraforms token and watch it animating on OpenSea, you're looking at an SVG file, which is output from the Solidity contract. This is what we mean when we say that Terraforms is an extremely on-chain work, right? You can actually get this SVG directly from the Solidity contract. There's no IPFS. There is a kind of a proxy web server in between, but it's strictly acting as a proxy. It's not doing anything. It's not interpreting the data, right? You could actually just get this SVG yourself, save it on your hard drive, open it in a browser, and see the animation, which is one of the things that we've done during this process. And so basically the SVG itself is composed of a couple components. It has a binary blob of the actual font data, right? And then there are the actual glyphs themselves, the 32 by 32 grid of effectively letters, right, or glyphs. And then there is some JavaScript and CSS code which governs the cycling of the letters. You can think of it a little bit like a mechanical display in a train station, right? Flipping through numbers on a board. Actually, 3D for Mathcastles posted some really cool artworks that were using that stuff, which is why it's on my mind in the Terraforms Discord today. But it's a little bit like that, right? It's kind of like those clocks that flip through different kind of physical objects to show the time, right? That's a little bit like what's happening in the Terraforms, where we're flipping through characters to create some of the animation. And then there's a second layer of animation, which is happening with the colors, right? The moving color patterns that you see. And those two cycling animations are kind of what create the kind of rich hypnotic movement that you see in the final SVG if you're looking at it in a browser. And so that is kind of one layer of the Terraforms project. And for us, we wanted to make sure that we could interpret that and basically reproduce it one-to-one, which after about 2 weeks of work, we have successfully done now. We're able to display it with both different kinds of animations. There's still some details. Some of the more rare tokens have unique animation, which we haven't implemented the code for yet. But for the kind of base, most common set of terrains, we've got that working. The way that we did this was we started by basically recreating the custom Terraforms font in Unity. And Unity has a package or kind of a feature called TextMesh Pro, which allows you to take a font and turn it into what are called signed distance fields, or SDFs. And what this does is it keeps the font characters or the glyphs super crisp when viewed at a variety of ranges and magnifications. So it's almost a vector-like format, except in this case it's using 3D rendering technology because Unity is a 3D rendering engine. And so what we did first was convert the custom Mathcastles font into a signed distance field so that we could display it using TextMesh Pro. Then we set it up in a grid, right? We just created the static grid of glyphs that we would get from the SVG. And then we started to add the elevation data. And the elevation data actually is not in the SVG. And this is one of the things that is an interesting kind of way to understand the Terraforms artwork as a larger system, right? We have these 2D SVG renders that are what we see when we look at OpenSea, but there is this other data which is actually not used in those SVGs. So for example, the elevation. The elevation creates a 3D topology for these kind of plots of land art. In order to see that, you need to actually pull it out of the Solidity contract and combine it, or in our case, the way that we're doing it is combining it together with the data from the SVG, right? So this is an interesting kind of dimension of this being an extremely on-chain work, that it's not, the SVG is not the complete work, right? You cannot actually see all of the data that's there by looking at the SVG or even by decompiling the SVG, which is effectively what we've been doing. You need to actually address the contract and pull data out of the contract to start to create something more like the true visualization of this kind of invisible hyperstructure that the Mathcastles developers have created. By combining the elevation data with the data from the SVG, we were able to create this kind of first topological representation. And one of the developers on our team had the idea of standing the characters up on end so that they look like in the one particular token we're using, it's got these kind of tombstone looking characters so that they look really cool standing up. And it's just a super simple, fun idea, but that brings the 3D dimension to life. And once we had that, we could start to display the characters and the topology. And then we went to work on rewriting the JavaScript code, which is in the SVG, which governs flipping through the characters. And that was the next thing that we were able to solve. One of the devs on our team basically rewrote that code into C# and was able to get it so that we had the effectively black and white version of it, or white version of the Terraform, performing the correct character cycling animation. And then finally, just yesterday, we got the final character animation ported over to C#, and we were able to display finally the one-to-one accurate animated 2D version of our test plot. We've been using token 556 as our kind of test token, that we've just been using the same token again and again. So we were able to display token 556 in its full animated color with the character cycling animation in there. And it's kind of a funny, I posted the GIF in the Terraforms Discord, and I'm like, this is not just from the website. This is completely resimulated, and it looks the same, right? It's like a little bit, if you didn't know that it was running in a game engine, it wouldn't be that visually exciting, right? But then what one of the devs on our team did was actually take that and render it in its 3D with the topology and all of the animation. And that for me was is a really cool moment, right? Because now we're getting to something that we've never seen before, and that we're now kind of rendering the Terraforms artwork, I don't want to say as it's meant to be, right? Because I think the kind of concept of the artwork is that it can be visualized in many different ways, and there isn't necessarily a single authoritative render, but we're starting to get this more rich three-dimensional render that combines the characteristics of the ASCII art SVG version and some of the on-chain 3D data that really you need something like a game engine to render. So that's a very exciting moment for us. And we've been posting in the Hypercastle Explorers Discord. I've been trying to put every kind of new significant development into the announcements channel and then also in the general channel so we can just discuss it. Please do join us there if you haven't already and you're interested in the project. And there are still Hypercastle Explorers tokens available to purchase. There are some on secondary, which are going for very reasonable prices. And there are still a number that are not yet minted from the contract if you want to go there. So if you're interested in being part of the project and buying some of the artwork, we appreciate that very much. It helps us to keep going and extends our runway out a little bit further. We're on schedule so far, right? Fingers crossed that continues to be the case. And then the next phase, basically next week, we're starting to move into, we're going to split the team and work in parallel on the 2D world visualization, so displaying a level at a time using the rendering technology that we've developed so far, and the 3D world visualization, which is going to be the much more technically challenging component, because we're going to probably have to do quite a lot of optimization work to display the 9,900 or whatever it is different Terraform tokens in this full 3D structure, which is pretty large, and to make that run on a regular computer at a reasonable frame rate, right? Which is always one of the big challenges of doing any kind of 3D game development, is making something that looks good and is also performant, right? So that's one of the next big kind of mountains for us to climb. But yeah, I'm really happy and excited with our progress so far. It's been great chatting with everybody who's following the project in Discord, and also in the Mathcastles Discord. We've been having some great conversations there. So if you're not a part of those, please do join us. So yeah, thanks so much for watching. If you enjoyed the video, drop a like for the algorithm, subscribe to this channel to get new updates when they come out, and we'll be back again soon with another update on our progress. Thanks.